Today, we are continuing our series on embeddings. When most people think about embeddings, they think about Ada, OpenAI, just take your text and throw it in there. But that's often too crude. OpenAI embeddings are trained on the internet, but your dataset most likely is not the internet. You have different nuances, a different focus, and also a different use case. And also, you have more than just text. So why not use it? Especially when text-only embeddings tend to fail. Today, we are talking to Mór. Mór is the ML lead at Superlinked, and we will dive into how they embed everything: categories, numbers, locations, texts, images, and how you can combine them to create a more robust, more relevant, but also more explainable search. Let's do it.
One very hindering limitation is only using text, as you said. For example, if you just simply go to OpenAI and make it embed the numbers from 0 to 100, and you would plot the cosine similarities between 50 and all the numbers, what you would expect to get is like a triangle-shaped graph. But in reality, what you would get is something that has the trend that you would expect, but has extreme noise. So like 40 would be more similar to 50 than 49 because 40 has a 0 in it, kind of stuff. So yeah, I think this is extremely limiting, and people are, I think, yet to see that, or I still experience people expecting to just pour everything into a text embedding model and expecting it to do magic and work well. But like having different data embedded in a more data specific way is definitely something that I think we need more education on as a community.
Do you think if we get smarter with how we represent different data as text, we can work around a lot of the limitations we have currently?
Yeah, so on the one hand, I think thinking in text will always have the limitation of thinking in the next token prediction. And that approach in itself has its limitation. I don't know if you've seen the example where people ask GPT-4 if some number is a prime. And the model always answers with yes or no. That's the first token. And if that's right or wrong, that has a big risk. And if it's wrong, it will try to argue for the wrong answer because now the token is predicted, so you can only predict the next token. So there's that, I think, which is like a very significant problem that arises from text. And there are also different accounts out there that there is a limit to. I'm definitely not an expert on this matter. I just read some paper abstracts talking about this, but they say that there is a limit to how much language can be an efficient medium to convey intelligence. So is language the way to artificial intelligence? There are like a heated debate right now if that's the way to achieve that.
I think language is very lossy. It's a bad compression in the end. It's really hard to express even what I want to have built.
Yeah, you always end up writing algorithms or dummy algorithms because yeah.
How would you actually define unified representations of data?
Oh yeah, that's a very, really good question. The way we like to look at it is, let's imagine that you are a company doing a lot of stuff that you would want to be data driven. And the unified representation is a good enough representation that would power all of these use cases that you would want to do. In our case, for example, we believe that analytics, semantic search, a recommender system, or a personalized reg can be driven based on the same vectors that you create on top of your data. For example, you could, as an organization, have the same user vectors that would drive the personalized reg system, that would drive what content would we recommend next to the user, and so on. I believe what you should strive for in terms of unified as an actor in the place is unified in the sense that it would power all your use cases. When I joined in more than 2 years ago, we were building a personalization engine. So we were wanting to be the engine behind personalized experiences online. So updating vectors, user vectors, updating content vectors, And we could imagine this happening in like social networks, media outlets, basically any online experience that has some personalized content aspect to it. And when we were building out that product, at some point we realized that actually what we are building here, the approach, is much more broad. So actually what we are building here is a vector computer. That's when we pivoted and started to call ourselves the vector computer, which is essentially a middle layer between data sources, the vector DB, and the applications trying to use all these vectors. So like maintaining the data transformation into embedding, store them in a vector database, and then through the query functionality, power all the use cases that would somehow benefit from these vectors.
Maybe let's start from the inverse. Is there anything that cannot be turned into embeddings or that isn't sensible to be turned into embeddings?
Wow. Nice. I haven't really thought about this before like this. I know one thing. Location is tricky. Location is tricky to be turned into vectors because you could create these spherical coordinates that way you could turn GPS coordinates into points in the sphere of a unit. What's a circle in 3D? A sphere, right? A unit sphere. So points on a unit sphere. But the problem with that is that it's very hard or nearly impossible to scale the distances. So you would have people compared to the whole hemisphere of the Earth, people in the same city or 200 kilometers away would be like extremely close to each other because the whole representation spans the whole globe. And it's really hard to create a representation where you could scale that distance away so that you could create meaningful distances inside a city, for example, that would be like useful for something. Like a global location representation that you can scale is something that I've tried to create but failed miserably. So that's one example I think I can mention.
And now the other side, especially for recommendation systems, because I think there is more data that is actually turned into embeddings. What are the different things you actually embed in a recommendation system?
I think the most important distinction with recommender system data is whether it's content data or whether it's like behavioral data or interaction data. In terms of content, I think recommender system is not very different from other use cases. You could have text, you could have timestamps, categorical data, whatever is there in any other semantic search use cases. And I think when it gets really interesting is the interaction data or behavioral data. For that, I think everybody knows collaborative filtering or like in general matrix factorization methods, which are really interesting and really useful in this vector-based recommender system case, because you could basically have a vector part that refers to the content of the item that you are trying to sell, like the embedding of the image of the dress, embedding of the description, embedding of the category, whether it's a skirt or a t-shirt or whatever. And you would have a different vector part that would somehow embed the consumption patterns of the users. These vector parts would be closer between dresses that are frequently bought together, for example. So this way you could model in the same vector both aspects of the product. Yeah.
And how do you actually combine the different embeddings, and especially in recommendation systems? So I have, for example, the embeddings of the images, the product description, but also metadata, different categories, maybe even some numerical values, the sparse vectors of the different tags and categories. How can I combine the different vectors?
I think when you think about this, you should definitely start from the distance function that you're using. We specialize on dot product similarity, which is a more general case of cosine similarity. And essentially, it just works like adding up the multiplication of the corresponding vector index items, basically. So like a sum product in Excel, for example. And if you go from this direction, one important thing to realize is that you can basically just times 2 a vector, and the similarity will be times 2. So you can pretty easily weight stuff. And also, if you have different vector parts concatenated together, if you times 2 one vector part, then that vector part's contribution to the similarity will be 2x. So these are really simple mechanics that you can make use of in a multimodal vector case. So stemming from this, what we do is we create the individual vector parts that refer to each aspect of the data, each a different embedding. We always normalize them, and we can recircle what's a useful normalization in that case. So these, and then we have these normalized vector parts we can then concatenate, and then we can also do reweighting on top. So like I have 3 normalized vector parts, but I do realize now that I really want the fresher items. So I would give more weight to the recency-based vector part, and then it would contribute more to the similarity between items. So that's basically the approach.
And how do you actually decide which parts of the data should have their own embeddings and when to add new embeddings from different modalities or different parts of the data?
In that question, I would always start from the query patterns. I would always think that what would our users want to query from this data? And if we know that users prefer popular content in their feed, then we know we should embed the like counts and the comment counts on posts. Or if we know that this is a news site, so we want recent news articles to be on top of the page, we know we need to embed the creation timestamps and give more weight to them. I think that's an algorithm that we came up with on a company retreat in Montenegro. It's essentially very similar to positional encoding, or definitely gets the idea from positional encoding. What we do is we project a time frame on a quarter circle, and where now, or like the point of query, is a definitive point, like the point where cosine is 1 and sine is 0. And so if you go back in time, the cosine similarity will be proportional to the time spent. And the good thing about this is this. So the hard thing about time is that it passes, right? So you create an embedding, and in the next second, you would have to create a new embedding if you don't do something smart. And what you can do is at embedding time, you can decide that, okay, I will want to re-embed my data a day from now. So let's create embeddings that are valid for another day. And that's the trick, to set the point in the quarter circle to be like 1 day from now, calculate back the time frame from that time, and embed the timestamps based on that time frame projected on the quarter circle. So you would have valid recency embeddings for another day.
What speaks against filters, pre-filtering or post-filtering in the results, or also using a re-ranker to basically re-rank based on the recencies and just using the scores?
Yeah, that's one of my favorite topics. I feel that people are very lenient towards re-ranking, because if you think about it, vector search is like blazingly fast, like extremely fast. And building any layer on top that kind of re-ranks the results from vector search is like a magnitude slower. So it will increase your system's latency a lot. So I would think, based on this, that I need pretty strong justifications. So I should re-rank, so I should pre-filter. And I think I have yet to see these reasons. So I think most of the aspects that people are re-ranking for can be expressed in vectors and can be pushed into the vector search. Actually, there is one thing that's not really compatible with vector search, and that's when at recommender systems there's always this notion of make the results diverse. Now, vector search results inherently will not be diverse because they will be like similar to the query, right? Of course, there are techniques to do that, but I think that's the only occasion I've encountered in my career that there is an aspect that's not that we cannot push into vector search and make it and express it through vectors.
And if I would want to transfer it, So for example, if I want to embed numerical quantities, so for example, I'm doing a company search and I want to embed, for example, the revenue they have, how would you actually go about creating a new embedding for this new type of data?
Yeah, so in this case, this is a numerical data, so I would use our number space. The number space is embedding numbers is, I think, the most varying based on the task you are doing, right? Because if you have like a regression model, you would just put the number in the model and it works. Or maybe you do a log transform if it's like power law distribution, but not much of a fuss. It can handle it. But for vector search, you can't really use the number itself in the vector because then you would have a 1D vector that you cannot scale, you cannot do anything with it. It's just a monolith, you cannot touch it. That's very not beneficial for that purpose. So for numbers, we are doing something quite similar that I mentioned in recency, that we would have a range, like a min max, and we would embed the range, project it to the quarter circle. And what you can also do under the hood is do some logarithmic transform. If you have skewed power law distribution data, you can add like log 10, so it would skew out this inconsistency and make the space more like log scaled.
Yeah, and I have a case where we are in the financial space and we use a post filter, for example, based on the revenue. And the issue is if you have a minimum amount of items you want to return, if you're using a filter, that's very hard because the filter could throw away more items than you would want or you would want to return. So you basically have to do a second pass through the entire retrieval system. And if you could embed that in the vector space, you could basically circumvent this.
Exactly. That's a very important problem we often encounter, that using a binary filter and expressing some more elaborate preference for some value is a very different thing. If you can only have a binary filter, then where would you put the filter? You can't express differences between items that make the filter. So you lose a lot of expressive power with these filters instead of smoothly blending these different aspects together through vector search.
The categorical and ordinal data,
Mm-hmm.
how do you go about embedding those?
Yeah, so when you think about categorical data, I think, so there is the case where you have labels. You can do magic like target encoding. That's something I encountered to be, and please don't be mad at me, to be like the lazy solution. Because most of the times when you want to do target encoding, you could actually do something smarter, but you are just lazy, so you would just impute the target variables. I'm happy to debate this later if anybody wants to talk about this. I know it like pushes all the buttons for everybody. So yeah, if you put this aside and let's imagine this is an unsupervised case and you don't have labels, I think you have two major directions you can go. One is just essentially text embed the category name if it's a telling name. Like if you have, let's say at e-commerce products, you have skirts or you have t-shirts, it makes sense to embed those with a text embedding model because then you would have categories that are semantically closer or further away from each other. So that makes sense. But let's look at another case when you have categories like A1 or like B3. You wouldn't semantically embed those categories. I would say that the best approach here is like the naive approach, which doesn't expect any kind of relation in the data, which is like one-hot encoding essentially. Because that way, all the categories are orthogonal to each other. There is no differentiation in their relationships. So you could use that to express relations that are only dependent on the category itself. There's no other notion in the embedding.
What about the ordinal data? Because I think ordinal data for me is one of the most challenging because usually there is meaning in the different categories or ranks.
Mm-hmm. Yeah. I would probably just go and number embed it. So I would just use our number embedding because this way you still have the kind of the ordinals, so the ranks you would still have them. The only difference is you would have like integers instead of floats, right? So you would not have items between categories, but that's I think so. That's exactly what a number space would do. If you have 10 categories that are ordinal on the range, you would have 10 points where like 10 different representations of like sines and cosines on the quarter cycle.
If I now have my item representation, so I have the text, maybe an image, maybe some additional metadata, which I can embed as categories or as numbers or whatever, what impact does the embedding size of these different embeddings have on the overall system, on the weighting, and the retrieval at large?
Yeah, that's also a very interesting question. So one lucky thing is that dot product scales extremely well, right? So if you create like a 10x bigger vector, the dot product will take 1.1 time, 1.1x time. So luckily it's not a big issue, long vectors in terms of vector search. What can be an issue is memory, right? For example, if you think about Redis, which is an in-memory database, if you have too long vectors, you can hit some memory barriers there. So that can be problematic. I think we see all this quantization thing happening in embeddings. I think that's something that we should keep a close eye on and use in our systems as well. So don't store float 64 numbers all the time if float 16 or float 8 is enough. And now you have like quarter memory usage. Yeah, I think these are important. And in terms of the semantics, so the weighting and everything, what you have to keep an eye on is the relative weights of the aspects themselves. So you can easily switch some embedding off by setting it to 0 weight. You can easily pile it up by increasing the weight. So I think that's the main thing I love about our approach. And that's a lesson learned hard in the previous company or the previous product that we built, that fast experimentation with these weights is probably key to like good performance. And if you have to always re-embed your data set whenever you change some parameter, that's painful. So you would want to push all the levers that you would want to tinkle with further down the line to the query level, which way you don't have to touch your knowledge base and you could try a number of configurations because that's the good thing about dot product, that it's symmetric, right? So you can alter your query vector. It will be the same if you alter your knowledge base vector. So you can just make your changes on the query vector and iterate fast.
Are you already playing around with dynamically weighing based on the query? So for example, if I have a very visual driven or formulated query, that you pay more weight onto the image embeddings as opposed to the text embeddings?
Absolutely. So that's definitely something the natural language querying feature is doing. Tries to find the intent behind this natural language that the user types in and the sets weights based on this. And another approach is that if you are lucky enough to have like a uniform set of weights that applies for all your users, you can as a developer also preset those. But I think the more interesting case is when every user has a different weight preference. And in that sense, I think one step we did is the natural language query, so that the underlying instructor model can detect all these intents and set the weights accordingly. And also, if you have labels, you're lucky enough to have labels yourself, you can also train a model with even like user-specific weights that would set them dynamically for you.
How do you actually evaluate whether a new embedding adds additional signal or information to the retrieval?
Yeah, this again boils down to whether you have labels or not. If you have labels, you can basically calculate like IR metrics, and you would have a proper eval, and you could say that it lifted MRR or it lifted DCG, or maybe I said the acronym wrong, but whatever. And yeah, if you don't have labels though, that's a more interesting question. What I see us and our customers do is A/B test, try one with the embeddings and without for a limited time and observe the results. Or what you can do in some cases even is eyeballing the results. Like try your most common queries and see if you like the results more than before. That's probably a first step you do to even justify going on an A/B test or running some eval script.
How do you see going into a joint embedding space versus going into separate embedding spaces for the different data representations? So, for example, using polygamma for embedding images and text into the same embedding space versus using separate embedding models for image and text.
That's something I think the most interested in right now is these multimodal embedding spaces where you can shoot in with some text and get back some images, and it's the same vector space. So what should be noted is that when you have an embedding space with concatenated vector parts referring to the different aspects, you have a similar vector space. What's different is you have more dimensions. So it's a larger vector space, that is for sure. So that has all these like memory implications. But on the other side, what it brings is that you can weight the different aspects of your data differently. So for example, let's consider the same use case. I'm searching with text and want to get back images. I can do this in both cases. In the multi-vector embedding case, I would set the weights accordingly that I don't have an image now, I only have text, and would search in the vector space this way. So what you get for more dimensions or more storage needed, what you get is explainability. So you can always explain what part of the query triggered what part of the vector that comes back. So what's the contribution of each data modality to the query result, and get the weighting option, right? So you can easily even tune it based on the results you get from explainability. So I think that's the trade-off here. And yeah, everybody should decide which is more important for them. There's also maybe one more aspect here is the first is a very like non-trivial task, right? So you have to train a pretty complicated multi-headed encoder model, create some very elaborate representations. While on the other case, you can just take models off the shelf and do it quite in an unsupervised way on your end. So you don't need anything, you just run it on your data.
How do you actually see the different output sizes of the different embeddings of different embedding models? Have you any experiences which sizes are completely unnecessary? Because nowadays it seems like we're going up to like 10,000, 20,000 for some models.
Yeah, I think it's interesting because I think part of the reason these sizes are going up is that we want general purpose embeddings to perform extremely well in very niche tasks as well. And what we're trying to achieve here is like bloating up the embedding size. So maybe a general purpose model will be used for question answering and machine translation and everything. It will be good for it. So I'm not in the position to judge whether this adventure will go well or not. But what I do sometimes is I try to tinker with embeddings by putting them into some dimensionality reduction model to see if there is some like leftover information compression that the makers of the embedding model failed to do. And I never ever found any. So like these spaces are pretty tightly compressed and nicely created. I would say that maybe what we need is like more specialist models and like appreciation for specialist models more. Like this model is for search query relevance, and it's extremely good in that, and it's 512 dimensions. I think it makes sense if you think about it, right? Normally what justifies having that many dimensions is having to reflect that many aspects. And if you can use all your aspect budget on a specific task, in theory, you could more easily succeed. And maybe different tasks need different things. It's quite obvious that semantic similarity and like search query relevance are not the same thing. So I would want a general embedding to make the same meaning question, two question meaning the same thing close to each other, while I would want a search query relevance specialized embedding to have the answer to the question close to each other, right? So different purposes might need different models.
I think you guys are at a very special position that you're working with so many different embedding models. I would actually love to know what are the libraries and frameworks that you guys are using or you guys grab the most when it comes to embeddings.
Yeah. So I have a love-hate relationship with sentence transformers. I like it, but it's also sometimes feels like an academic project. So like from 2 to 3, there was some pretty major performance downgrade, which you can hack yourself around, but it's just not nice. So there's this, but also it's really handy. It decides your poolings for you. So I like it. I also like it, but in an ideal world, we will soon might not use it. And in general, just working with vectors and arrays, I find NumPy obviously to be an awesome choice. It is very fast. It has very handy functions to do all these vector operations that we do. And yeah, otherwise we are trying to keep the code as plain as possible. So we have some like old kind of like bare architects that are always asking the questions, is the use of this package justified, or should we pull in another should we depend on another like not entirely professionally maintained library? Should we not? So I think we are really trying to keep it simple and also keep it the fastest possible. So for example, like using NumPy was justified based on the fact that NumPy is far superior to operating with lists, for example. Right now, what we are experimenting with, I can probably tell that, is putting basically some PyTorch Lightning-based adapter model on top of our embeddings. So if you have labels, you can in theory fine-tune your embeddings with this adapter layer on top, and then you could use that. What is really strange again is that when I experiment with only a text embedding and I have some labels on top, and I would want to train an adapter that would make the text embeddings better for that specific like classification problem or whatnot, I have very rarely been able to come up with a uniform like weight distribution that makes the embedding better if it's general purpose. So again, I feel that the guys creating these embedding models are doing a good job, because you can't just really train an adapter on top. If you see, Llama Index had this example where they introduced the adapter model. Like on their own example, they could create like half or 1% increase in performance of the downstream model. It's really hard to make these embeddings better with these adapter models. We are creating connectors to vector databases. We are churning them out as we speak. We have Redis and Mongo ready. We have a small in-memory implementation to play around in the notebook, and the others are created based on client demand. There's a way to influence that. Actually, I think on our GitHub you can vote on an issue if you want a specific vector database connector to be developed. So yeah, I think your arguments are valid. Like, it's not extremely efficient if you have sparse vectors. That's true. But in some cases, the main thing you want from this application that has a VDB behind it is to be like fast. Like, you want someone loading the page to be fast. If that doesn't happen in like at most half a second, you lost the person. Like, attention span over, tab closed, done deal. So yeah, sometimes you might want to battle with some inefficiency if at the end you would have like very low latencies that are required in this case.
How do you actually balance like being in production but still doing the updates with new embedding models or new parts of the embedding?
Yes. Yeah. Like I think that's one of the hottest question in like maintaining a real-time up-to-date search index. I think even Amazon in their managed solution promises to be up to date in 2 hours. So I think that's a considered amount if you think about like places where in 2 hours the whole world changes, like in Twitter, or I don't know. So yeah, I think our general approach is have small approximate changes when doing the online system. So let's imagine you have a system that's online, that's running, and there is events coming in that would alter the vector embeddings. What you would do is smaller approximate changes that are easy to calculate and easy to do. Here, an important note is whether the VDB will automatically add a change to the index. That's something that Redis does instantly. So you change some vector and it's instantly part of the index. Not all vector databases do that. So that's something that you have to be mindful when deciding what VDB to use under Superlinked. But yeah, so that is one aspect. And the other is do regular heavy weighting through some batch workload like PySpark or something like that would do the precise heavy lifting calculations, switch the vectors, and leave the stage back to the online system for doing the small daily, so like through the day, intraday updates that happen to keep everything up to date. And that's if it's just a text embedding model. I think it's not particularly complicated. The model doesn't really change through time. But if you have a graph embedding model, depending on user interaction data with products, now that gets more interesting. Like, with what frequency would you retrain the model? Because you can just re-embed, like a new product comes in, you can just re-embed it. That's easy. But if you would want to change the vector of an existing item, that can be tricky. So that you need a good strategy for.
I think this is really interesting, especially I didn't know that the Redis is updated instantly. I think you always have to use a combination of something like a Redis cache plus your main storage engine, so that you don't really have the race condition.
Yeah. And if you have infinite money and infinite memory, you just use a very big Redis.
Nice. What do you see in the future with adding new modalities?
Yeah, I think so. I think the piece that we need to find out here, and I'm not really an expert in this, but having to create a good representation for vector search for this data. Because if you think about it, if we would have a good representation for like audio data or sensory data for vector search, we could just create vectors and we could observe like a previous malfunction, use the data before the malfunction, search in the vector space. And if you see a similarly behaving sensor, we can do predictive maintenance. So if we have these representations ready, I think this kind of boils down to the classical machine learning use cases we can do through vector search, I think, and so like really a lot more efficiently with these low latencies and easy pipelines of just searching in the vector space and returning the closer vectors.
What would you say is missing from the space?
I think that's an important piece. So like having a Hugging Face for all kind of data, if you think about it, can I just take from the shelf a model that embeds like sensory time series of temperature measurements? It's not that trivial. If we had that for all data modalities, I think building extremely interesting and useful stuff would be a magnitude more easier. That's for sure. And also there's cost. I think maybe to a lesser extent than before, but still running these big models is expensive, or calling APIs is expensive if you have considerate load. So that could go down even more. That would be nice.
And what's next for you guys? Like, what's on the horizon, what you can already teaser?
Yeah, I think in terms of the product, we are working on some evals to, on the one hand, give tools to people wanting to eval different embeddings and different setups on their system. On the one hand, give tools to them, and on the other, create benchmark performances on well-known datasets to have a way to compare using just the text embedding model to a more detailed, more fine-grained multimodal vector space for the same problem. That's definitely an area of focus for us now. And I can't really say much about these, but I think there are really interesting partnerships cooking right now. So you might expect to find us in your favorite tool powering search for you.
Nice. And if people want to start building the stuff we just talked about, where should they go?
Yeah, interesting. So What I can say is I think I benefited a lot from like general purpose machine learning, because I always say when you think about normalizing vectors, it's like when you standardize your data for clustering, for example. You do the same thing. You start from the distance function and you realize you would need certain distributions of your data in order to have like an equality of opportunity between variables, so to speak. And so this kind of like relationship, this kind of understanding of the space, I think is very well comes from machine learning or like traditional machine learning studies. So I would definitely start there. And in general, I think I would urge people who want to work with embeddings to like learn machine learning and understand the difference between training and test data, like the bias variance trade-off. So yeah, I think that's the most important thing. And you know what makes extremely hard these days to learn this is the extreme amount of noise. Everybody claiming that this is now the model that changes everything, and probably it's not. And like most of the cases, they are not changing anything. And you can easily get lost in reading like 10 papers a day and still know very little about the space. This noise filtering, this is, I think, like having people sending out these newsletters where they try to boil down this information for people. I think that's a very useful thing they do. So I would probably follow some people and subscribe to their newsletters. One more thing I would like to mention is that we are like babysitting an open source project called the Vector Hub, where people can upload their pieces on vector search, and we help them edit it, help them publish it. So that's something where where for the content I can vouch for, because I'm involved in the editing. So that's something that's useful. And also maybe one more thing I would like to mention is the vector database comparison table that we are also babysitting as an open source project. That's also useful if you look for a vector database but get lost in all the non-up-to-date documentations. There you can see a lot of different aspects of these databases and compare them and choose the one that you would like to use.
If people want to follow along with you and Superlinked, where can they go?
Definitely follow our CEO and co-founder, Daniel. I think his page is like the pure gold for following Superlinked. And of course, we are on all the popular places like LinkedIn, Twitter. And yeah, but on the first place, I would suggest you to follow Daniel on LinkedIn and check Vector Hub regularly.
So, what can you take away? What can you use for your applications? I think, first of all, you can embed way more than you would actually think. I think we've heard that also from Amar Shakir in the re-ranking episode, that they played around with adding metadata into the text to actually embed the information, like, for example, times and locations, and use those in the re-ranker, which work good as well. So it makes sense that you can embed different types of information. I think also his point that with sparse embeddings, the assumption that the different categories are orthogonal to each other often doesn't hold. I think this is very use case specific, and you have to figure it out on your use case. So if you have a set of categories, are the categories completely unrelated or are they not? And then you can decide like how do you handle them. And if they are not orthogonal to each other, you might be better off, or not unrelated to each other, you might be better off using something else or one of their techniques. I think embedding time dimensions and different numbers is probably the thing that's most interesting to me. I already mentioned in the episode that we have a use case right now where we have a set of results we actually need in the end, but we have a bunch of filter conditions. And we basically have a recommendation system, but we have a fixed list which should come out in the end, which is a target. And for that, it would be really nice if when we would have that in the embedding already, we can just take the top 100 results. How our system is set up at the moment, we basically do the retrieval and then apply like a post filter after the retrieval. And this, for one, requires us to return more results than we actually need. But at the same time, it can happen that our post filter throws away more results than we actually want. So we have to do another pass through the retrieval and then deduplicate them basically, and then do a new basically fusion, because we then have to rank the two passes of retrieval anew, which is very laborious. Also, like, the performance on OpenAI on numbers, I think this was something to be expected. Since LLMs cannot really handle numbers that well, why would we expect regular embeddings to do well on them as well? The explainability of embeddings is something where I agree in some kind of way. You have more explainability than if you use a singular embedding, but also you don't really know where it comes from. You know that the high similarity might be through the categories, but why do you have high similarity? That's still for you to figure out, and especially if you have something like image embeddings and text embeddings and you have a search, you probably won't be able to figure that out. But also, I think like adding or combining multiple different embeddings might be really interesting for some systems, especially like in product search, where you actually have a visual component, where you can use images, where you have a lot of metadata. And I really want to try that stuff actually out, especially with embedding numbers, locations, and stuff like that. Yeah, let me know what you think. I'm really curious what people think about whether the approach would work. I will try it out. If you're interested in what my results are for my search applications, just give me a ping and I might do a post or another video on that. Otherwise, also let me know what you think of the episode. If you want to hear more of that, we have a bunch of additional episodes on embeddings coming out in the next few weeks. Subscribe, give me a like, and if you have any topics you would love to hear more about, as said, hit me in the comments, shoot me a quick message on LinkedIn, on Twitter, wherever, and I will most likely respond. Yeah, I will see you next week and have a good one.